All right. Hey, everyone. Hope we're all doing good today. I'm not going to do it. I did the
Always remember,
central.
if you ain't first,
You're last. How's it going? He looks my favorite nerd. There we go. I'll take it. Um, how to dawn? How am I? Or you're saying howdy? Wait, oh, how's? Oh, I see. Ah, I get it. So, how is Dawn? Okay. Dawn is doing pretty good, you know. He's just chilling. Uh, I thought it was. I kind of want to. I wanted to throw in a stream yesterday, just doing some like I don't know factorial or Talos principle or something, but I ended up just working on stream stuff and getting more alerts and stuff like that. Um, there's like so many games that I just want to play that I'm super excited for it, but I feel like I just don't have enough time. You need to that, that's a lot of work. Yeah, I mean, do you use stream out elements too? You need to redo your tax stuff too. Oh, um, I won't have to do that until like January, but I don't know how it's gonna go. This is the first year that I've been a streamer, so you do use stream modes? Yeah, it. Oh, jeez, I'm coughing like you now. Stream elements is kind of a freaking pain. Like, I really don't like their interface. You don't have to until December. Oh, okay. Don't you always cough when you stream? I feel like you complain about that a lot. You know what? Your mom coughs. Yeah, sorry, that might have been too far. Wait, this is weird. Don't rush to wake up tomorrow. Oh, thank God. Are you gonna be late? 18 hours. Okay. Oh well, I still have to wake up in that case, but I don't have to wake up as early as usual. That'll still be nice. Okay. I don't really. I don't get the purpose of this either. Oh, I thought I've said that, but um, yeah, no, I like I wouldn't want to stay up until like past midnight just to, like stream, so I wouldn't expect you to either. So well, I'm just a better person than you, I guess. What can I say? So for this, they understand how to change the function, but they need it in a specific format. The name of the constants isn't the same across each of the formats as well. which I think is adding to the confusion. I think part of the confusion here is constants won't be possible to have the same A in each of these formats. You could make your end results, what was their end result? That? Oh, thank you, Central. I couldn't figure that out. Wait. Isn't this right already? Uh, Basically, they have near the same thing, but with like the A, B's, and C's. But there's a slightly different form over here where the A, B's, and C's won't be the same. But it's kind of weird. Do math for 5-year-olds. I think we should start you off with like 3-year-olds, and let's work our way up from there. Hey, Budib. Quantum Mechanics for Babies is a banger. That'd be an interesting book. Wait, so they do have the right answer, but they just have it as like, it's very rigid. They could just stick the 23 in front. And it's the same thing. Should be a complex analysis for babies. That'd be nice. Do your 3 times tables. Hey, that's something. Goo goo gaga. Square root -1. It's stuck. Oh, I see the joke. However, your end result of f of x equals negative x plus, oops, x plus 4 squared. I am the joke, yeah. You write the 23 first. -23 minus x plus 4 squared. Well, wait, did you have actual times tables like just for one number? Like the way the times tables were taught for me is like you just have one big table. Why? I'm pressing enter, it's just making a new line. Why do you do that to me, Google? It's like, this is how I was taught. But it looks like, or like, 1 times 1 is 1, 4 times 5 is 20. They did have them on one table too? Okay. It looks like this is a separated version. Oh, it's way too blurry. Kind of pattern people didn't really mention speaking of. Oh, I could see you like finding patterns in that and like being a little math nerd. My first math theory was, this was before I was even in school, is that 1 plus 1 must equal 11 because 11 has 2 1s in it. So clearly 1 plus 1 must be 11. Oh, shoot, is it pronounced too risky? Or I hope I'm saying that right, but welcome in. I couldn't stick around for your stream for too much yesterday because I was super hungry, but it was interesting to see you at it. Wait, why is my command working? Is it gonna work? Wait, is an iPod just not working right now? Is an iPod asleep? Well, too risky streams, and you should check them out. Let me part and reconnect. I actually disabled the commands thing for Nightbot. So that one's not supposed to work. Okay, Nightbot is now my channel. What's a random command? Saves. I'm gonna use Jed. Okay, good. Nightbot is awake now. There we go. I don't know why it lost the connection, but I just parted it and rejoined it. You just want Dawn to stop talking. There you go. Wait, did it work for Central? It did work for Central. Me shouting out Central at the start of the stream broke Nightbot, apparently. You're special, yeah. I don't know why you would need it in that exact format, because it's still basically the same as Vertex form as you stated. Mother told you every night. um does satisfy the question's requirements. Okay. I think this is a good answer for this person. I hope it is. So I think they did it right. It's just the question is so specific that it's kind of confusing. You approve? Thank you, Central. All chess and no math makes Jack a dull boy. Oh god, that's very true for me too. You don't spell though? Oh yeah, you did mess up. What you lack in P's, you make up for in R's without a proof. Let's go to homework help. Don't look, click a random one. Spice this up a bit. These all have comments on them. Okay, here, I'm gonna scroll randomly. I'm closing my eyes and I'm covering them. And then I'm gonna click somewhere here. It wasn't even a link that I clicked on. Well, okay, I basically clicked on that one. Oh God, why? Oh, ooh, ew. What the hell is this? How do you integrate that? Maybe you could multiply by like 1 minus root x plus 1, but let's actually look at the comments of this. Click on the nth one right and it shows my... Oh, yeah. That one, that wasn't real. Inverse hyperbolic trig. You need a... Ooh, that's a... Inverse hyperbolic trig. I'm going to plug this into Wolfram Alpha. I want to see what Wolfram Alpha says you're supposed to do, because this one looks disgusting. 1 over 1 plus square root x. Oh, wait, no, let me use the actual symbol because I know that's going to mess it up. X, because it might be kind of a fun one. Yeah, no, I do notice that Wolfram Alpha likes the hyperbolic functions when you can also use ln's. Actually, that's not that bad. What does Wolfram Alpha say to do? You do rationalize it. I've never seen rationalization with 3 terms, though. So did they multiply by 1 minus root x and just left the root x plus 1 alone? Whoa. Okay, so honestly, I'm not a huge fan of the or I think I can give this person a better hint, because you can probably do this problem avoiding the hyperbolic trig functions. And this person said that they didn't learn them anyway. I didn't learn them either. I just know a little bit about them. So we do need to figure out how exactly Wolfram Alpha rationalized this denominator, but let's see if we can figure it out. So we have integral 1 over root. Oh, wait, let me write it in the same order as it was presented. I don't know why I erased the entire thing, but I did. 1 over 1 plus root x plus root x plus 1 dx. Do you have the fake feeling you haven't learned any math ever since your childhood or adolescence? Yeah. Especially when I feel like I regress in my math skill if I don't practice it. Well, I don't feel like it. I know I do. So it feels like it was kind of like a waste to have studied it, but if I keep it up, I don't. If I keep my skills up, I don't feel like it's a waste. So for this, oh, how would Wolfram Alpha rationalize this? I'm kind of tempted to multiply this by, let me write the original first. I kind of want to multiply it by 1 minus this entire thing. I don't know how it's going to work out, though. Because this is like 3 terms. Should I do? You know what? Let me actually give just the inside part. So I feel like this is going to take a lot of algebra to even like do all that multiplication, and I don't want to waste that much time. So let me, I'm going to cheat a little bit with Wolfram Alpha. 1 over 1 plus square root x plus 1. I hope they give me step by step just to rationalize this. Oh no, that's the derivative. We do times the one that I was thinking would be a rationalization. Just for me to cheat. I'll get you a cat drawing. Subtract the bigger root. Only subtract the bigger root. All right. I'll trust you. Thank you to Risky. Actually, well, I'll still plug into Wolfram Alpha because I'm already here, but thank you for that. Oh, wait, yeah, of course Wolfram Alpha just cancels it. All right, let's just try it then, because Wolfram Alpha isn't even going to help anyway. These notes feeling fake a couple days ago when you saw YouTube shorts of a guy talking about n to the 1 over n sequence, and I paused and answered the relevant question before he asked it. Oh, yeah, that's true. You didn't finish, but it does look great. Okay. Central. You're so aggressive, but that is a save. You're right. Let's actually just, well, you know, we gotta try it and make sure that it works out, you know. So on top will be the same. On the bottom, 1 times 1 is 1. Which one I'm gonna do like the 1 multiplied into that. So 1 plus root x plus root x plus 1. Then we do this times all of those. Minus root x plus 1. Root x times root x plus 1. Oh god, I don't have enough room. And then minus root x plus 1 plus root x plus 1 is minus x plus 1. Okay. Let's simplify that a little bit because that looks horrible. Okay, so x plus 1 minus x plus 1. 1 plus... Wait, we have a plus 1 and a minus 1, so let's get rid of those. Okay, those go away, those go away. We have root x minus root x, x plus 1 minus x. That looks like it's factorable. I don't know if it is, though. I guess it's factors back into what we originally had. Did you get something different, Risky, or am I missing something? Because it doesn't seem like it's what we want. If we factor out a root x, does that do anything good? I don't think so. Huh. Thinking about it. You need all three terms. Oh, I see. You have to do plus root x. Okay. Like that, hopefully. Oh no, I don't mind it too risky. Like unless sometimes if I do like a for fun problem that's just like a challenge, then I might say that I don't want hints. But the point of this is just to, like do homework help. So I want to make sure that I have like the right answer. So I definitely don't mind people chiming in with hints. I know we'll probably do that math on the bottom for me. So that's where I'll cheat. Yeah, I do need all help I can get. Copy this, paste it, minus. It's really boiled down to 2 root x? Wow. Wait, is that what the what this thing had? Oh wait, I could have of course I could have just gone off what the numerator said to figure out the rationalization. Why does that? Okay, I guess I'm gonna do this manually because this doesn't match with what is over here, so maybe there's something else going on that I shouldn't uh cheat too much with Warframe, I guess. All right, let's do this the old-fashioned way. 1 times 1 is 1. I'm multiplying the left into the right. So 1 times all of those minus root x plus 1 plus root x. Now multiplying the root x into those plus root x minus root x plus 1. X times root x is just x. Now multiplying the root x plus 1 into all these. That becomes minus x plus 1 with no square root. And then we get a plus root x plus 1. Okay. So these two and these two go away. That and that go away. Plus 1 minus 1 go away. 2 root x plus x minus x. It is 2 root x. Why does Wolfram get something different? Or like it gets... Huh. That's still a save, because this is probably a better form to work with, but I need to figure out... How do, how do you guys make it so that you turn the problem sheets back to the professor? It seems I'm unable to. Like, give your professor a problem? Or do you mean like you're trying to use like an online thing? in life? Do you just... So wait, why do I get 2 root x? 1... Oh wait, it's the minus root x. It's supposed to be plus root x plus 1, but minus root x. Okay. I messed up the minus sign. I said if I'm going to match it Wolfram Alpha I wonder if it's possible to do it from this step, or with this rationalization too. Oh, I just thought someone posted something in the math questions channel. Their Discord name is SO. Are you here in chat right now? I forget who that is. Oh, I see, Boodib. I don't know. I personally, like, I didn't have that problem, so it's hard for me to like say that much about it. Oh, thanks, Central. I was about to message them. I want a link. So yeah, since we do have someone who's asking, there I got it. There I got it. Oh, you're hearing me twice. Probably skill issue, booted. So I'm gonna put a pause on this problem just because I prioritize questions from chat over random things from Reddit. And this one, I don't think it'll take that long to explain anyway. Okay, so this is the problem here. And you're allowed to use a graphing calculator here. And they kind of tell you what to do. So we can go through and execute that and try and explain what we mean. If that person, let me check the user list right now. I don't see them, or I don't see a name that matches SO. Let me just added them to hopefully get them in here. I'm gonna bring up Polynomials and Desmos. They say to use GeoGebra, but I'm more familiar with Desmos. Come on. But I'm opening it now because it takes 10 years to do with this browser. I'm still not seeing them pop up. It might... Okay, how about this? I'm gonna go back to working this integral until I see them come in, and if they don't get here in a few minutes, then I'll just do it and send them the VOD of me explaining it. Okay, so with this, I actually did the wrong rationalization. I wonder if this would work too. Like if you did u equals root x, it's not the way the Wolfram Alpha did, but this might be another valid way. I kind of want to try the integral with this way. Just see where it goes. Where to put my marker? So if you know this is equal to that, let's plug that in and we'll do a u sub. I wonder, can we just split this up into different fractions? Okay. Ideas. Dx. And so if, I wonder, this might just be easier if we split them into 3 different fractions based off the numerator. Hey, Spherical. I'm good. How about you? We're doing a cursed integral? Yeah. For your homework and you're so lost. So are you actually in the stream right now? They just talked in the Discord. Sorry, I just want to see if I can actually get SO in here. Am I so good that we can be doing? Yeah, exactly. Okay, they just need a second. Okay, so from this step, I'm thinking we can split up into 3 different terms because 2 of these will be pretty easy to integrate on their own. Minus root x plus 1 over 2 root x. And then root x over root x will cancel, so we just get 1/2. Now the only challenge will be doing that middle term. If we did u equals root x, do we get something nice out of that, I wonder? Let me go up to the other corner. So first off, let's do the parts of the integral that are more easily done. 1/2 root x, that just integrates to root x. And then I'm going to skip and do that part. 1/2 integrates to 1/2 x. And then we have minus that middle term, which will now become the last term, just to keep things organized. Dx. And now on this, I think we do u equals root x. Which means du is 1 over 2 root x dx. And I'm not even going to do u equals root x on that term. So I want the root x to cancel with that root x. And instead, I want to figure out what x plus 1 is in terms of u. Ooh, this might not be possible to integrate in the way that, ooh, it's going to get complicated. If we square each side of this, we get u squared equals x. So we could, I'm just going to focus only on the integral part right now. We could say that this x is u squared, and that the 1 over 2 root x cancels with the 2 root x there. So we just end up with u squared plus 1 du. That's just, is that tangent? Or like inverse tangent? Oh, SO. Okay. I'll put a pause on this problem so I can work on SO's problem. Yeah, you saved us from doing this integral. Okay, so your problem was this. Given solutions to the cosine, does the equation have cosine of 9x equals 13 when x is between 0 and 2 pi? And they give you a hint to basically graph cosine of 9x and y equals 13 and count the intersections. So let's do that. I haven't really used GeoGebra much, so I was thinking that I would use Desmos here. So we graph, so I'm just a bit more familiar with Desmos. So this is cosine of 9x. And then we also have y equals 13 here. Wait. Why isn't it giving... Oh, wait. Oh, I didn't think about that. Okay, so basic, so what is, or so I'm not sure which one you prefer to be called, but basically what you would do for this problem is we have the red line is cosine of 9x, like the red like squiggle line, and the straight blue line is y equals 13. Just call you SO? Oh, okay, sounds good. And what you would do is you would count how many times the blue and the red lines intersect. But you can see like the blue line is way up here and the cosine function is way down here. So there actually are no solutions. They never intersect. So the answer to the question should be 0 because they just don't intersect. If, for example, instead of y equals 13, you had maybe y equals 1/2, here you see we do have intersections and we'd have to like count each one. It's like there's one intersection here, one intersection here, and here, and here. And 2 times pi is about 6.2. So you'd count the intersections all the way up to about 6.2. So this one, it's almost kind of like a trick question because cosine will never equal 13 without some kind of like shifting or things like that. But in this case, we don't really have that. Oh, yeah, I was wondering about that. Yeah, I hope that makes sense, SO. Let me know if you run into any issues with that. Um, oh, you have another one? Sure. The equation 6 sine 2x minus 5 cosine 2x equals 2 has one solution when we require that x equals 0 to pi over 2. Hey, Bri, how's it going? Find the solution and type it correctly rounded to at least 2 decimal places. Just write the solution and remember the decimal. Really? Engineer school? Oh, okay. So, oh shoot, let me do this. Here, I wonder, we could do this algebraically. Wait, that's actually a weird hint. Oh, maybe it's not a weird hint. Oh, okay. Um, let me pin the question here, just so if anyone comes in, they'll see it. So I'm going to let me draw a little box here because we do need to do some working on the whiteboard here. Actually, I wonder, but I might keep some flopping around. Let me try one thing. I hope this isn't making weird noises.
Oh my.
Hey, Jed. Okay. Yeah, the pinning thing is nice. Oh, it's cosine squared? Oh, no, no. I think it's just cosine of 2x. Take it off? Yeah. Things are just flopping around. Okay, hopefully I still sound okay. I'm just gonna put a little box around here and just work in this part. And my markers are dying on me. Man, the red one was the only one that was working. Let's see if blue is gonna write dark. So we have 6 sine 2x. I don't think it's sine squared based off the hint. Minus 5 cosine 2x is equal to 2. And they give you a hint, which is, wait. Oh, Jed, did you just pin a different one? I don't think it's squared. Oh, wait. Oh, you're right. So then it probably should be squared. I was thinking this is, I was thinking of sine 2x equals cosine times sine. So is this? No worries, Jed. Okay, so thank you for that. Should I call you Brian now? Or YY? So yeah, is the problem supposed to be squared for each of these? Oh no, the blue marker isn't. I need to buy new markers, man. Brian works? Okay, sounds good. It is sine squared. Okay, cool. You see, may as well try black and green too. Okay, so here we need to use the hint. Oh, black is doing good though. Okay. So 2, let me actually rewrite the initial problem because that's so faint. I don't know how it's showing up. It was 6 sine squared x minus 5 cosine squared. Equals 2. Okay, good. Oh, no worries, Jed. And so the hint is that 2 is the same thing as 2 times sine squared x plus cosine squared x. And that's true because of the Pythagorean identity. Sine squared plus cosine squared is just 1. And 2 times 1 is just 2. So you're allowed to say that 2 is equal to this. So let's apply this identity to the right side and see how that works out. So I assume that's going to be important. The left side will stay the same. Now I think we distribute the 2 inside the parentheses and we subtract everything over. So 2 sine squared minus 6 sine squared is 4. Minus 5 cosine squared minus 2 cosine squared is minus 7 cosine squared. Really? Equals 0. Oh, okay. I see where this is going, I think. Now let's add 7 cosine squared x to each side just to get, because it'll make more sense in the next step. Now we need to divide by cosine squared, I think. Let's divide by 7 cosine squared. I hope this is going to work out how I think it is. Is equal to 1. And now sine over cosine is equal to tangent. So this entire thing is equal to 4 over 7 tangent squared x equals 1. And then you can multiply the 7 over 4 on each side. Tangent squared x equals 7 over 4. Is this even true? we square root each side, get tangent x equals root 7 over 2. Maybe? You don't have to do a plus and minus here because we're restricted to 0, comma pi over 2. Maybe you do need a minus sign though. There's a way that we can verify this answer after, so. Markers stay there. Okay. I don't know if that's what we're supposed to have. This does seem like the logical conclusion based off their hint, but let's make it Wolfram Alpha's problem. So I want to know arctangent of square root 7 over 2. I don't know if this is even a valid number. It is. What is square root 7 over 2 though? Is that inside the domain? So we're restricted but to be between 0 and 2 pi, or pi over 2. That's more than pi over 2. So pi over 2 is, oh wait, no, you're right, Jed. Thank you, you're right. I was getting mixed up with the square root of 2, which is 1.14. Or I don't know what I was thinking, but you're right. It's about 1.6, and this is about 1.3. So, oh yeah, it's not, we don't need that anymore. Okay. So, the solution is, to isolate x, the only other thing we need to do is do the arctangent of each side, which is why I did arctangent in Wolfram. So x is equal to arctan square root 7 over 2. And then they say to do it in 2 decimal places, I think. So you take that, plug it into a calculator, and you'll get 1.32. I hope that makes sense, so let me know if not. And let me also plug the initial equation into Wolfram to verify that. You got something different with the OG? Oh no. Well, Wolfram is going to get every solution, not just the restricted domains solution. You're right. And we got just above 1. What did I do wrong? Why? The cosine, I mean, this almost looks like it matches. Wait, this does match, doesn't it? 'Cause if you do sine, or it nearly matches. If you do sine over cosine, it's 7 over 11 over 11 over 4, which is just tangent squared 7 equals 7 over 4. This does match, these two match with what I initially got. There actually is a much better way to solve this, isn't there? But why is the final answer different? I think my algebra is right. Yeah, I should be able to do arc sine 7 over 11. Roots 7 over 11. Oh, is it the square root? It's the same angle, though. Did I type in the thing wrong? Arctan square root 7. Wait, I typed it in wrong. Oh, did I include the 2 in the square root? No, that's a different number. Okay, I got the right. I typed it into Wolfram Alpha wrong. I don't remember what exactly I did, but it is 0.92. Okay. I think I just typed it in wrong the first time. I don't know what exactly I did, but this does get 0.92, or this does get the same answer that you just said, SO. So I think I did everything right, besides entering into Wolfram Alpha that one time. Thank you for pointing that out, Brian. All right, so let's unpin. No worries. See you around. Once you do go, I guess. Okay, so if you have anything further, let me know. If not, I'm going to go back to doing a random question from the internet. Okay, so we had this doozy of an integral that we were partway through on. Let me erase the there. Okay, so I'm going to put the integral of root u squared plus 1, and you do a tangent substitution on that. I think you do u equals tangent squared. I'll use v, I guess. So du equals... Oh, no, I'm sorry, not tangent squared, just tangent. Secant squared. V dv. Okay. So, that means we get secant squared v times root tangent squared v plus 1 dv. You have 5-question tests that you need help with. Oh, is it an actual test, SO? If you're not allowed to use outside help, then I shouldn't have even helped you with those other ones. If something you're allowed to use outside help with, then I can help you, but if it's a test, then I can't. It's not a test? Okay, okay. I was not sure it was a translation issue or something. And yeah, I wouldn't trust ChatGPT with anything. Yeah, if you want to post the next one, no worries. So we've done 2 of them. Get a cough drop. Yeah, if you want, post the next one that you need help with. In the meantime, I'm going to keep on working on this integral until you post yours. I'll switch over. Okay. So tangent squared plus 1 is the same thing as secant squared. My Pythagorean... Actually, let me not assume things. Dan, how's it going? I'm working on this little butte right here. As well as some questions from Wadis, aka SO in chat. Home solutions is the equation. Okay, so this is the same form as the other question that we just did. So where are you confused on this type of question, SO? It's 1/5? Oh, instead of 15? So for SO, I'm sorry, SO for that one, where are you confused on this one? So it's the same type as we did before, so I don't want to just say the same thing again and have you not get it. Yeah, so there won't be like a box that says like number of solutions and then a number. You have to actually count where they intersect. So did you get the proper graph? Oh, okay. So your graph should look something like mine. So it does look like there's infinitely many solutions, but they restrict you to be between 0 to pi over 2. So let me, isn't there a way to do this in Desmos? Like specify a domain? Dude. I thought there was. I don't know, but basically if you're restricted between 0 and 2 pi, you only look at the intersections starting from 0 and going right up to about 6.2-ish. Let me see if I can just get the screen so it's more or less between... There we go. So basically, count the intersections that are just... You only look between 0 and... Let me get the exact value, I guess. You look for any solutions where the x is between 0 and 6.28. So you really just count the intersections up until you get something that's above 6.28. You don't go all the way out to infinity on either side. You only look at this kind of like window of the function. Oh, thank you, Jed. So yeah, this is it with the domain restricted, so you don't get the infinite, like the seemingly infinitely many solutions. So what we say the answer is here, if I'm not explaining this too poorly. where these two lines, where the red and the blue lines intersect, how many intersection points they have is the answer. Um, 6.2 is like the upper limit for where we look, but it's not the actual number of intersections. Basically, like, what the point of this problem is that if you have something like cosine of 5x equals 1 over 5, you can graph each side of that equal sign on its own and find where those two functions intersect. And wherever they intersect is where the equation will be true. You're okay with that one then? Okay. Yeah, if you want to put the next one in. Mm. Ooh. So you're in a calculus class, right? SO? And hey, Abdul, I'm not very good with programming. So it's not really my forte. If you have like, if it's easy for you to type, you could try to put your question and maybe I can help, or maybe there's someone around who can help. But I'm not the best with programming. Okay, so you are in calculus class. Okay, I just want to make sure that I'm not going to use something that they haven't seen before. Okay. Black marker. Oh yeah. Jed might be able to help. So we have y equals 3 minus 8x. Um, 1, 2, 3. It's kind of important to get a semi-decent graph for this question. It's not, you can do it without a graph, but it's nice if you graph the line here. Three minus 8x. So our y-intercept for this line is 3. And it hits the x-axis when y equals 0, which is also at 3, x equals 3 over 8. So I'll just do 1. And we get a very steep line, something like this, I think. Even then, that's not a perfect drawing, but we don't need it to be that exact. And so basically, we have a triangle that's like this. Let me actually put a little box around this because I don't want to lose this work. Basically, we have a very steep line here. We need to put a rectangle inside it using the x-axis and the y-axis. And we need to maximize the area. Okay. So it's going to fit inside this triangle. Let's just name a random point here and see what kind of rectangle that forms. So I use this point and we go down. This height is the same as the equation of the line. So y equals 3 minus 8x, whatever our x coordinate happens to be. And the width of the rectangle is just x. So the area of a rectangle is length times width, and that's what we want to optimize. So area is equal to length L times width W. And in this case, we have our length and width in terms of x, because we don't know exactly what they are. That's what we want to find out. So we can say that x is our length, let's just say, and we say that our height is the equation of the line, 3 minus 8x, with the way that we set this up. Abdul. Oh, you know, I think that is something I've done before, but not in a long time. You can put it in my Discord, though. I guess you can put it in the coding channel. That's towards the bottom of the list. All right. Yeah, so if you're still with me so far, we set up the equation for the area underneath that line, which is just whatever x coordinate happens to be as the length, and the height is the equation of the line. So I hope that part makes sense. And if we want to optimize the area, okay, cool, you're still with me? If we want to optimize the area, we want to derive our equation that we just got and set it equal to 0. And when I say optimize, I mean find the maximum. So let's derive it and set equal to 0. A prime is, let me actually do another step here to multiply the x inside, because it'll make deriving it a bit easier. When you derive 3x, you get 3. When you derive 8x squared, you get minus 16x. That's our derivative. Let's set it equal to 0 now. Subtract 3 from each side. Divide by negative 16. You get x equals 3 over 16. So that's the x coordinate where our biggest rectangle happens. Actually, we technically should verify that it's a maximum and not a minimum. It shouldn't be a minimum, but it's good form, I guess. And I think the simplest way to verify that it's a maximum is to do a double prime. Because you derive this again, 3 derives to 0, minus 16x derives to minus 16. The second derivative is always negative, which means any critical point we get is always a maximum. I think that's the simplest way to verify that that's a maximum. And the actual question wanted the largest area. So we're not like quite there yet, because we need to get the actual area when x is 3 over 16. So let's go back to the original equation. We can use that one, I guess, and plug in our x value to get the actual area, which is the final thing that they wanted. A of 3 over 16 is 3 times 3 over 16 minus 8 times 3 over 16 squared. That math is a little bit annoying, I'm going to be honest. Let me 9 over 16 minus 16 times 8. I got this. 80 plus 48 is 128. Okay. And then you multiply this by 8 over 8. 9 times 8 is 72. 72 minus 9 is 63. So your final answer should be 63 over 128 there. So I hope that that makes sense for that one. No worries. And I think you said we've done 4 questions, right? So you have one more? I didn't actually check that, Jed. I don't think so, though. I think that would only happen if it's maybe 45-degree triangle. We got x equals 3 over 16, which means the y is 3 minus 3 over 2. Which is just 3 over 2. So no, it's just a rectangle, not a square. Have to use translator? Okay, no worries. Take your time. The area was 63 over 128. Really? What's wrong with it? Oh, it probably 63 over 128 probably simplifies, or does it? I don't know. No, it is irreducible. Yeah, you're right. 3 over 16 times 3 over 2. I might have made an arithmetic mistake. SO. Oh, shoot. Yeah, I made it an arithmetic mistake. That's what I get for doing mental math. Sorry, so the answer should be 9 over 32 for the final area. I don't know what I did wrong, but I did something wrong. Oh, it should have been 16 times 2. I did 16 times 8 in the denominator here. Oops. Here's your problem. You should just get 9 over 32. Okay. So yeah, this is right. I just shouldn't do mental math. That's my problem. Let's take a look at what Abdul put in the Discord. Just out of curiosity, I said I don't know if I can do it, but while we're waiting for SO anyways. It works, but it doesn't print the last node after the merge function is called. Merges 2 ordered linked lists. This looks like C or C++. That's a nice hint for the crazy integral square root problem. Oh, okay. Yeah, I think with the trig stuff, I'm getting a little bit nervous that I went down the wrong path because I did deviate from what Wolfram Alpha said to do, which makes me a bit nervous, but in case someone doesn't want to see the hint, I'm going to take my Discord down for a second and look at it. Oh, so do that rationalization instead. Yeah, I wonder if there's a couple ways. It's like Wolfram Alpha suggested even a third way to do the rationalization. Well, actually, this is near the same thing as what Wolfram Alpha said. I wonder if there's multiple ways to do it. So I went down with like my own rationalization, but that's kind of out of like curiosity. It might not be a good thing that I did. Oh, really too risky? I think I'm getting towards the end, so I'm just gonna like see it through. But I might try it both ways, just because integration is fun. Looks like Jed is working on this coding one, and it's gonna take me way too long to understand what's happening here. So let me I'm just gonna go back to working on the integral until I see SO put their last problem in chat. They still need to translate it, it sounds like. Okay. So I'm going to erase this triangle optimization one. So, oh yeah, I was going to look at the Pythagorean. Yeah, so I haven't seen you post it yet. Did I miss it? No, I don't see that you posted it yet. Here it is. Okay. Well, so we just did this exact type of question before. So I don't just want to do everything for you here. So have you tried this one for yourself, or like are you stuck on how to get started? I'm not going to go through all the steps here. I can help you get started, but this is something you should learn how to do without outside help. Okay. Let me know if you get stuck. Let me just verify the identity for the tangent squared plus 1. It should be secant squared. Yeah, it is. Okay. So going back to this integral. Well, SO works on that. Tangent squared plus 1 is secant squared. Square root of secant squared is just secant. So we end up with secant cubed v dv. And integrating that, how the heck do you do that? You could, if you float a secant squared, I don't think that really helps you. When you derive secant, you get secant x tangent x. What is the trick that you want for that? Let me put this into Wolfram Alpha too. I was using Wolfram Alpha for everything right now, I guess. You get 0.90, you don't think it's right though. There's a reduction formula for secant? Oh my god. They did some weird integration by parts thing? Okay, this is weird. Yeah, to get the rationalization might be better. I'm gonna put, let me see if I can verify your answer. I won't show it on stream though. 9 sine 2x, or squared x. Arc sine. Looks like the right answer is 0.91, so there might be a rounding error there. What was the first step that you did, SO? You might have done it right, it was just the calculator rounding it differently, or there might be an algebra mistake. All right, maybe I should just do the other rationalization. Because integrating secant cubed is, it's not pretty. Yeah, I can't come up with a better way to do it than Wolfram did. Okay. I guess Wolfram wins again. Let me, this integral is just kind of fun, which is why I don't mind spending so much time on it. Let me do the other rationalization that it's the same as Brian suggested. That Wolfram Alpha also came up with. I wonder if there's actually a different step that I could have done there rather than splitting up into different fractions, but I already erased it, so let's not. I'm just gonna erase everything. Do it all in black. And so I'll switch back to what you're working on once you tell me what you tried or what your first step was. Actually, let me see. Was there anything new in that Reddit thread? I should refresh it and see if someone else commented. Oh, there were a bunch more comments. Flex score positive income. Yeah. So Gamma Rayburst actually posted a response here. I still want to solve this integral for myself, but I want to see what Gamma Rayburst said. And thanks, Jed, for helping out Abdul. Wait. That's the rationalization that I did. No, never mind. That's Wolfram's rationalization. Okay. Oh. Okay. Growing the best beer on Twitch? Exactly. I know what that's like. Okay, so I think Gamma Rayburst's response is pretty complete. I think this integral is just fun though, and I want to do it anyway. So 1 over 1 plus square root x plus square root x plus 1. And then the rationalization we're going to do here is 1 minus root x plus root x plus 1. I don't really know how this like counts as rationalizing or not, but or like how it works when you have three terms. I assume that there's a lot of valid paths, and that's actually what Gamma Ray Burst said as well, but this seems to be the easiest one. Okay, so the top stays the same, 1 minus root x plus root x plus 1 over. Now I'll do this multiplication the old-fashioned way. 1 minus root x plus root x plus 1. Then the root x by all those. Minus x. And this into all those. Gonna need more room. Okay. We have minus root x plus root x. Those cancel. Minus root x, that all that stuff cancels. You get 2. Really? Wait. Oh, but use the slightly different, like use the negated version of the top and bottom. I'm doing it this way because I ended up with 2 root x in the denominator before, and that led me to integrating secant cubed, and that was just messy. Maybe there's a different way to do it after a point, but I didn't see a way to avoid that secant cubed, so I switched. Minus x and plus x cancel, so we get a 2 from 1 plus 1 and a 2 root x plus 1. Dx. Let me verify that. Yep. Okay. This does match Wolfram. And then Wolfram does u equals root x plus 1, which is probably a good idea. So du is 1 over 2 root x plus 1 dx. Okay. Ooh. That 2 there is going to mess with this. We don't get cancellations as clean as I would want. Let's just plug it in though and see what happens. Oh, also, if u is equal to root x plus 1, that means that x is equal to u squared minus 1. Okay, so the 2 here is going to cancel the 2's there and there. That one stays the same. Root x is u squared minus 1. That root x plus 1 is u. And we also have the root x plus 1 on the outside here, which is just u. The 2's canceled from before, so we get 1 plus u du. This is the easy way, according to Wolfram? Or is this the way that Wolfram did? Okay, you know, if this ends up being too much of a pain, I might just call it quits, but... because it does already have an answer on Reddit. But I thought this would be something a bit nicer. If I can see some kind of simplification, I'll keep it going. If not, I should probably just move on, though. Oh, shoot, and SO, I still haven't seen anything back from you, so please do let me know. Uh, Thinking about this, there's some kind of factoring that we can do. Maybe there's like a +1, -1 trick. No, not in a helpful way that I see. Well, maybe. Maybe I see it. Okay. I think we have a 1 plus u here, and we kind of have a 1 plus u here. And I want to engineer it so that we get a cancellation with that. I don't know if this is the right path or the wrong path. But I'm going to make that 1 plus u a unit and say that this is equal to, let me make some arrow spaghetti here. This is, if I distribute this outside u in here, we get u times u plus 1 minus u root, oops, it should be a u. Wait, I just wrote x again. U squared minus 1. There we go. I know how to write, don't worry. Okay. And so I'm thinking maybe we split this up into two different fractions. And maybe something good happens, who knows? But this numerator I think is the same as that. Wrong? What did I do wrong? After I break up u equals x. I think this is right. It's for skin. Was that just a for fun wrong answer? I'm just going with this because I don't see what's wrong with this, so. I'm going to split this up into two different fractions. du. Now we get a cancellation there and there. Now for that, maybe we factor out that as the difference of two squares? You're joking? Oh, okay, okay. Oops, other way around. And technically we can cancel the u plus 1 and the u plus 1. We get a 1 plus u in the denominator. I don't know if that's good or bad. If this doesn't go anywhere, then I'll call this it quits for this problem. But I don't know. This type of integral is just fun to me. Is there anything convenient we can do here? Oh, no worries for skin. Maybe we could do a second substitution with like v equals 1 plus u and just try and simplify the denominator a bit. No, I think you're still gonna get some weird trig integral. Let's just try it, but I think it might have just ended up back at integrating secant cubed, which I specifically wanted to avoid. So if I did, I'm just gonna integrate that left one. Then over here, I do v equals 1 plus u, dv equals du. The v minus 1. So we get v minus 1 root subtract 2 from each side of this, I guess. V minus 2 or V, or is it V minus 3? No, V minus 1. No, V minus 2. V minus 2. Okay. That looks horrible. I don't think this is simpler. Maybe it somehow is, though. Now it's just kind of funny. I guess let's distribute that out. V root V minus 2 over root V. And you know, V over root V, well, it's not going to help us when we get over here, is it? That looks horrible. I think it's going to be some weird thing. Ah, oops. Okay. Maybe I've taken this integral as far as I want. It probably would have been better just to deal with integrating secant cubed. It just looks scary. I don't see anything convenient we can do from this stage. Okay. Well, let's look for another. Already has an answer anyway. I don't want to read Game Raber's response a bit more. So this rationalization whoa, wait. Where does this fact come into play? Oh, wait. Oh, rationalizing twice. Oh, then that's where you... Oh, okay. That's way simpler. I went off the deep end. You still have to integrate square root 1 plus 1 over x. Game Raper is saying to do u equals root 1 plus 1 over x. And write u squared as u squared plus 1 minus 1 to get 2 terms. Oh god, you have more 2 stages of partial fractions? Okay, yeah, I'm definitely not gonna go all the way down this rabbit hole, but that's a fun integral. Yeah, I think right here is where Game Raper discusses basically getting to the secant cubed case. But in a different way. But all right, well, let's move on. Let's look for a question that hasn't been answered yet. That's a fun integral, but it's like a weird flex. Yeah, I've seen that person post before. They're always super thorough, I guess. And I never had anything to add to their responses, I guess, which is says how like much they go into detail. I don't know if I can do this, but let's just see. Oh, these are their answers for C and D. I've never seen omega used for this purpose, but I guess it doesn't actually matter. X greater than 0, y less than 0. X squared plus y squared plus z squared is less than or equal to 64. You would want to do this in spherical coordinates, wouldn't you? Hey, you probably do it in rectangular as well. Let me see if I can, how well I can reverse spherical coordinates. And by remember, I mean, look up the conversions. Y is equal to rho sine phi sine theta. We would need that for that y right there. If x is greater, I would need to, I think I can do this. It's a pretty, as far as triple integrals go, it's a more basic one. Let's see, this is just an integration day, I guess, which I'm not complaining about. So let's, I'm having trouble visualizing the bounds, so I'm going to quickly draw this out. X, Y, Z. So X is greater than 0, but Y is less than 0. Or equal to, I guess. So we're dealing with this quadrant here. Or it's Z has no restrictions aside from the bounds of the sphere, because x squared plus y squared plus z squared is a sphere. And when it's less than or equal to 64, its radius 8, square root of 64. So we're basically going from positive 8 on the z down to negative 8 on the z as well. And it's kind of like a quarter of a sphere, I think is what we're integrating. All right, so let's set this up in spherical coordinates, because that just makes sense for me to use. At least it makes sense to me to use it. So we're going to start off integrating, I guess, rho first. Well, actually, let's figure out what y converts to again. Y converts to rho sine phi. Now this marker's dying on me too. Sine theta. Oops. And when we do spherical, we probably need a constant with the d rho, d theta, all that, right? Yep, we need this. dv is equal to that stuff. Times rho squared sine phi d rho d theta d phi. Okay. Okay, so looking at the order of integration, we're starting up with rho. We don't have to, but we will. Rho goes from 0 to 8. That's our radius. Theta, starting from negative y going up to the positive x, is what? 3 pi over 2 up to 2 pi, based off the unit circle. And then our phi goes from 0 all the way down to pi. And you remember how phi works. Oh shoot, I just realized that my screen was a bit wrong. Sorry about that. Okay, yeah, phi does range from 0 to pi. Okay, good. All right, integrating this. Rho times rho squared. That's what we want to focus on first. 0 to pi. 3 pi over 2 to 2 pi. We are integrating basically rho cubed. Rho cubed integrates to 1/4 rho to the 4th from 0 to 8. Sine phi times sine phi is sine squared phi, sine theta, d phi, wait, d theta d phi. It doesn't really matter, but, well, it does matter. We have to keep them matching with the integrals. D theta d phi, okay? 8 to the 4 divided by 4. 8 cubed. Oh, 64 times 8. I should know this, it's a power of 2. It's 2 cubed times 2 to the 6th, which is 2 to the 9th, which is 512. But we have to divide it by 4. So it's 2 to the 7th, which is 128. I should verify that. I should not do this entire thing mentally. Let me plug it into Wolfram Alpha quick. 1/4 times 8 to the 4. 1024. I was way off. What the hell? I don't know what the hell kind of math I was doing in my head. Okay. So that is equal to 1024. When you plug in 0, you just get 0, so who cares? 3 pi over 2 to 2 pi 1024 sine squared phi sine theta d theta d phi. Okay, now we have to integrate theta. We just have a sine theta. I'm going to bring the 1024 outside. Sine integrates to negative cosine. Theta, I would from 3 pi over 2 to 2 pi sine squared phi d phi. Okay. Let's come down here, right? The first part again. Okay. Cosine of 2 pi is positive 1, so there's a negative sign in front of that. Cosine of 3 pi over 2 is 0, so we don't have to worry about that. So we just get a negative 1, basically. I'm going to stick the negative sign all the way on the outside. And all we're left with now is a single integral of sine squared phi d phi. And we want to do, I guess, a half angle. For sine squared. That's... Oh, or do you need to change it? So let me get it to show up on stream. Never mind, I can't. It's not. I'm just gonna write down what the identity is. I'm too lazy to fix my OBS right now. Oh shoot, my integral is partially covered up too. I'm just gonna get rid of this entirely. How about that? Fight me. There. Okay. Okay. Come up here. Make some math spaghetti. Minus 1024 integral 0 to pi. Sine squared of phi is equal to, gotta do some math, 1/2. I say I have to do some math, like I've been doing math this entire stream. 1/2 minus 1/2 cosine 2 theta. Or phi. D phi. I did that algebra right? Be stupid to mess this problem up just because of an algebra error. Okay, no, I think I'm good. This we can integrate basically directly. There's a little u sub for that term, but I'm just going to do it in my head. 1/2 integrates to 1/2 phi. Cosine integrates to positive sign, so the sign doesn't change. We do have to do a little u sub on that 2 phi, so we divide by 2. Minus 1/4 sine to phi, and we evaluate from 0 to pi. Okay, almost there. 1/2 times pi is just pi over 2. Sine of 2 pi is 0, okay. Then we plug in 0 here, that becomes 0. Sine of 0 is still 0, so we get a negative result? That's not right, though. I thought we'd get a sine flip. Dude, I really need to use the bathroom right now. And this person got minus 512, right? Yeah, they got minus 512 for that one. Let's let Wolfram Alpha do this, I guess, like usual. It's a livestream, just a Wolfram Alpha stream. Let's set up our integral. Oh, it's gonna be a little pain to type all this in, but we'll get it done. Three pi over 2 to 2 pi 0 to 8. I assume Wolfram Alpha will handle this symbol vomit. Rho cubed. Sine theta. Theta, where are you? Am I blind? There's theta. Now phi. It's like Where's Waldo, but with Greek letters. That's capital phi. Oh no, that's psi. Never mind. Dude, there has to be a phi. Nothing in life is free. That's phi. There we go. Okay. We said d rho, d theta, d phi. Okay. Hopefully, Wolfram Alpha, this makes sense to Wolfram Alpha. It is minus 512 pi. What did I missed a factor of 2. Oh, no, I got it right. It's pi over 2 times 1024. Okay. I just completely forgot. I didn't do minus 1024 times pi over 2 is, of course, just 512 pi. Okay, so they got the first one right. I don't know if we're going to do the second one. Let's just see what it looks like. It might be a cylindrical one, which might actually be kind of fun. Oh, wait. Actually, it looks more like it's spherical. Let me just make sure no one beat me to it here. Oh, okay, so Gamma Ray Burst did beat me to this one as well, but I might be a bit more specific on D if I can do it for myself and figure out what their error was. So look at what it is, though, see if I can figure out what's happening here. So it's nearly the same thing, except we have an extra restriction. Well, a slightly different restriction. How do we deal with this? Trying to visualize what we're integrating over. We still have a sphere, but it's going to be a different part of the sphere now. So x squared plus y squared is less than or equal to z squared, basically. Maybe you don't need to visualize it, you should just focus on getting the bounds right, but I don't know, I feel like I'm gonna get the bounds wrong if I can't visualize it. Can I do z equals root x squared plus y squared in Wolfram? Let's see what that gives me. A cone. Okay. And if z is less than that, x-axis, y-axis. So z is basically the bottom part of the cone. Or wait, no, z is greater than that, so it's the inside part of the cone. So I think, I don't know exactly where they're going to intersect, but I think it's going to look like an ice cream cone, where you have a cone on the bottom, and then a sphere on the top. And x is less than or equal to 0, so we only have 1/2 of that. I think we can achieve this because the cone, there's no transforms in the cone. The cone should just have a 45-degree angle with the xy plane. And so I think we can integrate the same sphere, but our azimuthal angle is going to be 0 to pi over 4, because pi over 4 correlates with a 45-degree angle. And that takes care of the cone thing for us, I think. Now, I don't know if I want to do another triple integral because it's going to take a little while. So let me plug it into Wolfram Alpha. But instead we have an x on the inside. X is rho sine phi cosine theta. We saw the sine phi. Okay, interestingly. Z is still 0 to 8. Theta, our instruction now is x is less than or equal to 0. So I think theta is pi over 2 to 3 pi over 2 now. And our azimuthal angle will be 0 to pi over 4. Minus 256 pi minus plus 512. Ooh. Is that equivalent? 8 cubed minus pi over 2? Why would they do 8 cubed out? Let's just see if it's equivalent. Eight cubed minus pi over 2. Just see how Wolfram Alpha does with that. That's different. Okay. So I think I'm going to give him a bit more of a hint for the second part. Square root x squared plus y squared less than or equal to z makes a cone. You're integrating from the cone up to the sphere. I accounted for this using spherical coordinates and bounds for phi ranging from 0 to pi over 4, since the cone makes a 45-degree angle the xy plane. Wait. Okay. So yeah, I did want to give them a bit more of a start than what Gamer Reaper said, which is why we're playing with this. Because just saying that it's wrong doesn't really help them figure out why it's wrong, I guess. Trying to find out the weight of dirt. Well, I mean, it's a very open-ended question. Honestly, I usually avoid the open-ended ones, but this one, it's open-ended enough that you could take a lot of different angles. So I think I want to tell them to approximate as like a 3D shape. I mean, I don't know, is it density of dirt? I feel like that's going to be all over the place, isn't it? Oh, okay. That's not too bad. I mean, rectangular hole, or maybe it's in a tile shaped like a cone. You can look up the formula for volume, or for the volume of that shape. Appropriate measurements, e.g., like the radius of the cone, which would be from the center of the dirt out to the edge. Then multiply it by the density of dirt. From Google, I see that 1.3 grams per cubic centimeter, yep, is a decent estimation, or is a decent starting point for an estimation. That'll give you approximately the weight of the dirt without having to actually weigh it. All right. I don't know why they need to know how much it weighs, but it's kind of fun to think about. Oh, I should have said the distance and the height. Of the cone and its height. So you do need that to figure out the volume as well. Whoever reply. From pi over 2 to 3 pi over 2. Those are the same bounds that I did. Result, you may have made an error on the actual integration in that case. Do I still have this? Oh, yeah, I do have this integral. Thank God. Yeah. Go back to Ask Math, just look for another question or two. Here's a fresh one. If x be a polynomial of degree n greater than or equal to 2, show if f has a local maximum, b local minima, and c points of inflection. Ooh. Then a plus b plus c is less than or equal to n minus 1. I guess you need to use the fundamental theorem of algebra for this. A local maxima, b local minima, and c points of inflection. Okay, I think, let me show us on the board. I think I know the answer. I don't know how rigorous they need to be, I guess, but I'm going to say it a bit more intuitively. Forgot to erase this stuff too. Okay. Oh my god, dude, this black marker leaves some serious smudges on my whiteboard. Okay, so f of x equals polynomial of degree n greater than or equal to 2. That means f prime x is polynomial of degree n minus 1. And then maxima, or I'll just say critical points occur at f prime of x equals to 0. And so by fundamental theorem of algebra, I'm going to abbreviate it. FTA, fundamental theorem, I guess you put an O, but I'm not. I don't know if that has a common abbreviation or not, but a plus b plus c to n minus 1. I mean, that seems a little like short, maybe not as rigorous as it could be, but I feel like that's all you really need. Let me go to Google though, and just remind myself of fundamental theorem of algebra, what it actually says. Make sure no one's already replied to it. Nope. Math is fun, sure. Yeah, a polynomial degree n has n roots. In this case, we have polynomial degree n minus 1, so it has n minus 1 roots, but you may have repeated roots, which is why you have to say less than or equal to. So if f of x is degree n, is a polynomial of, I had to pick up kiddo from work and get some prescription medication. Oh, okay. Fair enough. Hope all is well. then f prime x, of degree n, polynomial of degree n minus 1. The critical points a, b, and c occur when f prime of x is equal to 0. We can make a statement here. Actually, so I should leave the proof from here, but I mean, I basically nearly did it. From here, you would need to use the fundamental of algebra to justify the final step. Let me get a different link than math is fun, though. Something slightly more advanced, right? Let's see what this one looks like. Maybe that's too complicated. Here we go. I like this site, usually. Wait. There exists. It's not what I want. Okay, here we go. Part 2. I'm just gonna link the entire site, I think, though. Oops. I need to do it like this, though. Oh god, what did I do? Oh, this is going to, there's the parentheses that are gonna, it's gonna mess this up. There we go. This hopefully works. Okay, good. Let's look at this one. Total resistance of a circuit? Nope, I'm okay. Well, it might be the basic thing. They say it's just arithmetic. Actually, let me use the little preview window here. It should be under physics. I was hoping I wouldn't have to worry about the actual circuit itself. But it seems like you might have to. So I'm okay. I'm not going to do this. The person deleted their post? I wondered what's going on with this question. Ooh, okay. What did they say this was? Oh, calculus. Oh, okay, that's fair. Oh, okay. And here's the thing here. This looks complicated. Resistances aren't hard. I just don't remember them. I remember, like, is there like V equals IR or something? In serial, add them, but then in parallel, you have to do. I think I saw the formula when they were in parallel on that person's on the person's sheet. Okay. You know, I don't really want to do this question either, so we can go back to that circuit one and see if we can figure it out then. All resistor are 6 ohms. Teacher told us the answer was 0.45, but they somehow got 1.38. So wait, they got 6. Oh no, all the resistors individually are 6. The answer is supposed to be 0.45. Ooh, it's a little bit of a complicated one though, where you have parts that are in parallel, parts that are in series. So yeah, R4 to R6 would be 18 because they're individually 6. And then you treat this as one big resistor with R7. So 1 over 18 plus 1 over 6, and then you invert that again. Nine over 2. And then you treat this in parallel with, oh, okay. Okay, I see you. What were these other ones? Oh, wait, okay, let's look at their work. So that'll be 1/2 plus 9 over 2 is 10 over 2, which is 5. So you flip it, so you get 1 over 5. That's not 0.45. Hmm. Maybe did I do that part wrong? I don't think so. Let's see. Okay, so I got 18 ohms for that R4 to R6. Then R4, 5, 6, 7. What formula is that? Is that... Hey, Brian. They do get 4.5 at the end. I think they use like a non-inverted formula. Okay. So we got the same answer for that R4 to R7 part. And then you boil it down to this in the same way that we just did. And they apply this. The R's are all 6, yeah. So I wonder, we could take it from this step and just see if they maybe made an arithmetic error. Well, no, that's still going to be 1/5. So I get a third answer, which is weird. Their teacher said the answer should be 0.45. They say the answer should be 1.38. This is the original diagram up here. Yeah, sure, Jed. Just creeping back down to see what could have gone wrong here. I think they messed up their common denominator. Maybe they didn't. Dude, I don't know. Oh, you get 1.382? Okay. Or 1.38 as well. Gets 1.38. Oh, okay. I don't know. So then should I reply and say that I agree? Or I don't know. I kind of just want to not say anything though, because I don't know. I don't understand this for myself. Yeah, you treat this section up here as one big resistor in parallel with these three. So what they did down here too. Yeah. I do notice that the subreddit has like all the symbols here that you can copy paste. That's kind of nice. I should actually use that. So I don't know if I'm wrong or if the teacher's wrong, but I'm really not that confident in replying to this one. So I guess the link is out there if anyone wants to take it upon themselves, but I just don't really feel confident with this. Wait, didn't they? Oh, okay. So that's the teacher. I thought you were asking the person that's like, but they did post their work. I wish everyone posts their work like this. Oh man, they got all the symbols here. Okay. Teacher didn't show the work, so no credit should be given. Oh, I do have mail. Let's see what's up with that. Okay. So it'll open up for that triple integral. All right, to Risky. Thanks so much for hanging out. I was about to call it for the math part of the stream anyway. But yeah, hope you have a good night or whatever it is where you are. The hypocrisy inherent in the system. The proletariat will rise. I was thinking about what I want to play because the Outlast Trials had an update too that I really want to see. But Phasmophobia would also be appropriate too.